Hello, welcome back to the Physics 1 course. This title of this lesson is called A Review of Essential Trigonometry. So every single physics problem that you're going to work is going to seem challenging to you in the sense that no longer will the problem tell you exactly what you need to do to find the answer. So a lot of times, almost all of the time, when we get past the basic problems, there will be an angle of some kind in the problem. Maybe it's a plane like a wedge where a block is sliding down and the plane has an angle to it. Maybe a baseball is thrown at an angle. Maybe you're pushing with a force at 35 degrees. So, or whatever, I can go on and on and on. There's almost always going to be an angle in every problem. But you're never going to be told, hey, you need to do the sine or the cosine or the tangent of this angle. You're never going to be told that. You're going to need to draw a picture and figure out from your previous knowledge of trig in order what to do. You're going to have to do that yourself, and that's why these problems seem difficult. So in this lesson, we're going to review basic essential trigonometry. It's important for you to know that I expect that you have seen this stuff before. If you haven't, then you need to stop and go to my trig class, my trigonometry course, and review the basic idea of angles and stuff. And I am going to review as we go through, as we solve the problems. I'm going to baby step you as much as I can to review you, but still you need to have been exposed to this material. So the first thing we're going to do, the most important things, this is not a review of everything in trigonometry. This is the review of the most important things to solve physics problems. Right? So everything in this lesson is critical. Fortunately, none of it is really hard. So if you have a triangle, remember this guy? You talk about triangles all the time in trigonometry. That's what it's all about. So you have some kind of triangle, and this is a right angle, which means it's 90 degrees over in the corner. And there's some angle, like I told you, you might have a wedge. A lot of times in physics problems we have a wedge, and we call this angle theta. So theta, don't let it scare you. It's just another variable like x or y. This could be a 15-degree angle, or this could be a 35-degree angle, or a 70-degree angle, or whatever. Of course, as the angle increases, the steepness of this wedge, gets taller or whatever, but this is a general diagram here. Now we label the different parts of this triangle. We say that relative to this angle, the opposite side of this guy, we're going to label it opposite, OPP for opposite. And relative to this angle, this side right here is adjacent, ADJ. We call that adjacent. So adjacent means the side kind of close to the angle. Opposite means the side opposite the angle. And then the very longest side of every right triangle is called the hypotenuse. And I know that you all know that from basic math. Now also in basic math, you learn something called the Pythagorean theorem. Don't forget Pythagorean theorem. Don't forget that with right triangles like this, you always have the Pythagorean theorem at your disposal. The physics problem will never say, use the Pythagorean theorem to solve it. It'll never tell you that. You just have to know that you can use this for every right triangle. Pythagorean theorem, if the way you learn it in geometry, is c squared is equal to a squared plus b squared. In this equation, c is always the hypotenuse. It's always the longest side of this triangle. The other two, since they're added together, it really doesn't matter. Adjacent or opposite, it doesn't matter what you label them. So the way you read this in terms of this triangle that we have right here, since c is the hypotenuse, we'll write it as hypotenuse squared is equal to, and again, I told you it really didn't matter, so we'll just call it adjacent squared plus opposite. What does this equation mean? That means for any right triangle, no matter what the angle here is, whether it's 15 degrees, 30 degrees, 7 degrees, really slender triangle, whatever, it doesn't matter. If you know the length of the hypotenuse and you square it, and you know the length of this and you square them separately, and then you add these together,